Okay, as promised, this is an example of a problem like numbers 1 and 11 on the August 29th homework. So the question says, find an equation for the sinusoidal function shown below. Okay, so we've got this nice sinusoidal function. So when I say sinusoidal function, what I mean is something shaped like sine or cosine. Okay, so this nice wave. Now, in order to write down the form of the function, I need to know whether I'm looking at something that looks like sine or cosine, and then I need to know what a, b, and c are. Okay, so first of all, I'm going to say that this looks a lot like sine. Notice it passes through the point 0, 0. It's flipped upside down, but it looks a lot like sine. So remember, sine looks like this. So it passes through the point 0, 0, and it goes up and then down and then around. So this one goes down and then up, but it looks a lot like sine. It passes through 0, 0. So usually when I'm deciding which kind of function to use, if it passes through 0, 0, I choose sine, and if it doesn't, I consider choosing cosine then. Okay, so I'm thinking that this is going to be of the form y equals a sine of bx plus c, and possibly plus d, but this looks like it's centered around the x-axis. So I don't think I'm going to be shifting this vertically at all afterwards. Okay, so A, let's remember our amplitude is given by A. Okay, now A here is, so if what we're looking for is how far away from the x-axis this gets. Okay, so essentially half of the length from the very topmost point to the very bottommost point in the y direction. Okay, so notice this distance is 3. Okay, so this point is 1, -3, so we know that the peak or the valley, the bottom of the sine curve, occurs 3 units away from the x-axis. Okay, so our amplitude is going to be 3, whereas normally our amplitude is 1, now it's 3. Okay, the next thing we need to know is the period. Okay, so remember that the period is 2 pi over b. It gives us a way of finding b. Now the period is the distance from here till when we get back, when we start repeating that shape over again. So we start out going down, we're going from 0, 0, and we're going down and then up, and now we're back at 0, 0, and we're going down again. That's how I know my period is repeating. I'm going to do this shape exactly all over again. So I want to know what this distance is, okay, from 0, 0 to whatever this is. Now, one thing to notice here is that this distance from here to here is 1. Okay. Now, the sine function is going to be nice and symmetric. So if this distance from where I am at 0 to the peak is 1, then the distance from this peak right here to where we get back to 0 is also going to be 1. So in other words, this is also 1. Okay. Now this distance from 0 to 0 is the same distance as this from 0 to 0. So this distance is 2, same as this distance 2 here. Okay, that tells us that this whole distance is 4. Okay, so in other words, my period is 4. So b is not 4, but my period is. Okay, so 2 pi over b is equal to 4. Now we just need to solve for b. So 4b equals 2 pi, or b equals 2 pi over 4, which is pi over 2. Okay, so before, in a normal sinusoidal function, the period is 2 pi. Now the period is only is 4. That gives us a b of pi over 2. Okay. Now finally, I need to know what is the phase shift. Okay, so we call the phase shift a horizontal shift. It's just another word for how far off from the normal sine curve or cosine curve is this. Now this isn't actually shifted at all. So we have this point 0, 0. The point that this corresponds to on the normal sine curve is also 0, 0. So it's not been moved either direction. Okay, it's still 0, 0. So there's no phase shift. Okay, so remember that the phase shift is b over c. C over b. Okay, so this is 0. When I plug in what value I know b is, I get c over pi over 2 is equal to 0. This tells me that c is equal to 0. Okay, so we found a, b, and c. Now all that's left is to find out whether there's a reflection. Okay, and there is. The reflection is about the x-axis. So that tells us that the last thing we're going to do is put a negative in front of a. Okay. So now when we write this all down, y is equal to, we have this reflection about the x-axis, negative, our amplitude has changed to 3, and we're working with the sine function because we have the point 0, 0. Now b is pi over 2, and c is 0. There's no shift. So my function overall is just negative 3 sine of pi over 2x. Okay, so when given a problem like this, use the point that they give you to find the amplitude and the period. Decide whether or not there's a phase shift and what function you should be using, sine or cosine. And then lastly, find out whether there's a reflection about the x-axis. Those give you the values a, b, and c. And then all you have left to do is write down the equation of the function.